Hello and welcome to a video demonstration of the NDT Care software. After the program is installed, you'll see an icon appear on your desktop, which we highly recommend. After double-clicking the icon, the graphical user interface appears as shown here. There's a drop-down menu. We can first, from there, select Open File. We can then select the file type. The file type we're going to open for today is a text file. We also have legacy file formats such as ASCII and a CSV file format. A classic Windows pop-up appears where you can select the file. This file is on my desktop and it is called Sample Inspection. I will then click Open. Another pop-up appears asking if I want to decimate this data file. I'm going to say no decimation for this. Log file will appear saying that that file has been opened. The reason you would use decimation is if you have a very large file size, perhaps you are out on a 6-hour run or 8-hour run or something and it's gigabytes worth of data. File decimation can help you manage that file size a little bit more quickly depending on the speed of your computer. After the file is opened, I have two new selections. I can either insert time markers or display the LMA/LF charts. You'll only need to insert time markers if a pop-up appears warning you that the distance counter may have been missing or corrupted. That did not occur, so I will go right to display the LMA/LF charts. Another pop-up appears asking how many meters per tab. It tells us that the file opened is 89 meters long. What I can do is enter maybe 10 meters per tab. That will allow a nice zooming function. Then it'll ask if we want to display our data in a forward or reverse direction, and I will select the default of forward. After completing, you'll notice the graphical user interface pops up to the front and a log of the charts being displayed is recorded. There are additional things I can now do. Enhancement, calibrate, level adjust, and WRR. I'm going to do post calibrate, and what I'm going to do here, before I select that, I'm going to click on the actual window. Now notice here I'm going to do a zoom between -1 and 9 meters. So what we do in NDT Care is, if you remember in the calibration video, we put the calibration rod in and out 3 times, and you can see that here. And if you remember, it was about 6.3%, so that is what is recorded here. Now we typically do that, we put that in between -1 and 0 meters to show that. And so this is where I want to do calibration, so I can zoom on it and then go back to the graphical user interface and adjust these to where I want to do that. So now that I have that zoom, I'll go here and I'll do post calibrate. Once I do that, a set of crosshairs appear, and I'm going to select 2 points. First, roughly the low point on where the calibration is, and I'll say somewhere about there, and then a representative high point, so I'll say maybe right about there. Now what that does is it shows me the distance between those 2 points, and it's highlighted here. It's roughly 6.372, and maybe we want to make it just 6%. So that's something you can adjust based on what you want those calibration wires or rods to mean in your analysis. So I'll say 6%. And then after that completes, you'll see the LMA post calibration was performed, so a log of that. And you can see here with the chart title, let me click this, we've done the post calibration in the title, and you can see those 3 are now at 6%. The next thing I could do is a level adjustment, but since the level on those looks at it's about 0, I am not going to do the level adjustment. What I'm then going to do is I'll skip the level adjustment and go right to WRR, which is our wire rope roughness. This pop-up asks for a reference scan length where we talk about the rope lay length here, and the rope lay length is approximately 6.25 to 6.5 times the rope diameter. In the inspection, I believe the inspector said the rope was a 5/8 inch rope, which then converted to millimeters, and then multiplying by roughly 6.25 results in about 100 millimeters. So I will enter 100 millimeters here and hit OK. Once that's completed, a Once that's completed, this new plot appears where we have the LMA in percent on top and the WRR as a percent on the bottom with the scan length that we picked. Now we have a slider here that we can operate in a variety of ways that we have demonstrated in previous videos. I'm going to leave this as the default of 100 millimeters right now and hit Save WRR. And once that's complete, a log showing that we did the wire rope roughness with the scan length of 100 millimeters has been performed. I can click here and then, just like other plots, do a zoom. So again, we can see the WRR signal here in black, and then what we call the skyline plot here shown in green. We can zoom through here and see different views as we go through. Going back to the overview, let's talk a little bit about what we're seeing, especially now that we have the WRR and LMA. So after the calibration rods were inserted and we started the inspection here at distance 0, you'll notice this very large blip right here in the LMA, and then all of a sudden it goes down. This part right here is referred to as the remagnetization effect. So we have partial remagnetization in this area here, roughly between 0 and 4 meters, and then it kind of does a complete remagnetization here. Notice at this point where we have this sharp discontinuity where it goes to 0, this is where we did an LMA reset function within the data acquisition system, and then you'll see that we have everything sort of normalized to 0 here. And as a reminder, remember that roughly every 5 meters we had that weld, which you see here, and then we had this anomaly that we put into the rope here. So that is basically that classic inspection that we showed in the calibration video. So please note, if we do not do the LMA reset function here, your system will essentially go off with this remagnetization bias here. So to get rid of that, it is very important that you do that reset. As we're going in the inspection, at roughly the 40 meter mark, you'll see this, again, this big spike in the LMA signal. This is the inspection artifact where the inspector brought a piece of metal nearby and created this spike in the LMA signal and then removed it here. So what we see as we look at both of the remagnetization effect here and the inspection artifact down here, if we look at the WRR analysis here, what you'll see is that both of those, the inspection artifact is not shown here, neither so is the remagnetization effect in the WRR signal. So then what we can do with the WRR is essentially truly look at this as a inspection criteria for our analysis. After the WRR is complete, we can go and show the summary plots. And in the summary plots, what you'll see is the LMA, LF, and WRR with the scan length that we picked, sort of in a nice complete set. And again, we could click on this and then go through and do the zooming at various points and really do a more detailed inspection. Here again at the 40, you can see the inspection artifact shown in the LMA, not so much in the LF or the WRR signal. Finally, we could look at our histogram function, and when we look at the histogram functions, it's really over the analysis that we have of interest. So our crosshairs appear, and I'm going to pick outside of this remagnetization effect and say maybe we're going to start the inspection here. So I only want to look at the histogram here, and then I'll go pretty close to the end right here. So as a reminder from previous videos, the histogram will only be involved in the places where we had these light blue markers. So we're only going to do the histogram between those two markers, essentially ignore anything outside those markers. So a pop-up appears giving us a chance to rescale axes if we wish. I'm just going to say OK and use the default. Then a pop-up appears saying if we wish to set a maximum deterioration zone for the LMA, I will say yes. We can go over to this right here, which is our histogram between those light blue markers, and I'll say, hey, maybe I will pick somewhere in about this region. So this looks like maybe about 3%. So anything maybe less than this 3%, it's like, oh, wait a minute, maybe I wanted minus 3%. So I made a mistake here. So let me redo that and go to here, which is okay, maybe about minus 3% down here, saying maybe that's a limit of interest that I'm interested in. I'll accept that, and then it'll say the same for the LF signal. And so here I'll go to that same maybe 3%, and what you'll see here is both a plus and minus. It's symmetrical, so I'll just leave that as shown. And also the WRR for a deterioration zone. And again, I'll just stick with my roughly 3% as well. Again, these are based on limits that you desire for your analysis. And once the histogram's done, I can again zoom. So really my inspection starts about, maybe 15 so maybe I'll start about 19. And again, what you can do is you can see the very specific locations on the LMA, LF, and WRR signals based on the criteria we picked over here for our histogram. So again, those may be places along the rope that you may want to go look at. So again, if you had a 3% criteria, you might say, hey, somewhere between 19 and 20 meters, or 24, 25 meters. Again, we might want to go inspect that. Now, again, because this is our test loop that we have at our facility, this is, again, as you saw, a continuous loop where there's a weld, and that's the weld. So you'll just see this every 5 meters as we continue through. Then we can save the figures to Word. I'm not going to do that for this video. We've showed that in additional videos. The main part of this video, again, was to show you the inspection based on a more detailed inspection as part of our MRT flowchart for the calibration video that we had posted previously. So again, a more in-depth analysis of that specific case. So if you have any questions about this video, please reach out to us, and we look forward to hearing from you.